is the fourth and last example in the motional EMF lesson, and it's that of measuring blood flow rate. And what we're told is that blood vessels, they'll carry blood, they are in this case subjected to a magnetic field across them, and that because blood is conducting, that actually ends up developing a motional EMF V across the blood vessel. And we give it the diameter of the blood vessel, the strength of the motional EMF V that has developed. We know the strength of the magnetic field. And so using a particular device and knowing these numbers, we can actually measure what the blood flow rate is. And we're told to demonstrate that the blood flow rate, F, is given by this equation, pi d, the diameter of the vessel, V, the motional EMF, over 4b. So how do we go about demonstrating that? So let's first take a note of what F is. F is measured in cubic meters per second. So we'll keep that in mind as we discussed here. But now let's first say that the velocity of the blood flow is going to be small v. It's going to go into the right. So we know that small v, the velocity is given in units of meters per second. To get the blood flow rate, so volume per second, what we do is multiply the cross-sectional area, which is in square meters, times the velocity, which is in meters per second. So the blood flow rate, F, is going to be the cross-sectional area, pi d squared over 4, that's just the cross-sectional area, this is units of meters squared, times the velocity, v, and that's in meters per second. And again, the units here are meters squared, the units here are meters per second, so as we expect, the blood flow rate is going to be cubic meters per second. But this was a critical equation that we just had to consider how it comes about from what we're given. So then, we can already apply what we know about motional EMF. So we know that the magnitude of the motional EMF is going to be B, V, the velocity, times D. So now what we do not have here is the velocity, so we have to express the velocity from this equation in terms of the other knowns. So the velocity is going to be equal to V over BD. All right, so now let's put this in here. So then we get that the flow rate is going to be pi d squared over 4 times V, which is now V times the velocity, small v, which is now the capital V, which is the EMF, over B times D. So we see a factor of D cancels here, and what we're left is pi d, the motional EMF, capital V, over 4B, which is exactly the expression that we had to derive. And that's it.